So the main point of a Wittig reaction is taking a carbonyl group from an aldehyde or a ketone and reacting it with a Wittig reagent in order to create an alkene product. So in this reaction, it's a generic Wittig reaction, and you start off with a ketone and reacting it with some Wittig reagent. And the Wittig reagent is also called an ylide, which is a neutral molecule that has a negatively charged carbon bonded to an adjacent phosphorus or sulfur that's positively charged. As seen, the negatively charged carbon attacked the partially positive carbon in the carbonyl group, and the electrons shifted to the oxygen. So here the oxygen bears a negative charge due to the electrons shift, and now the carbon is attached to a carbon that is attached to a phosphorus pH3, and the phosphorus bears a positive charge, which is going to be attracted to the negative charge on the oxygen. And when those charges combine, it's going to form a cyclic intermediate, as shown right here. So in a cyclic intermediate, the oxygen is going to have a bond between the oxygen and the phosphorus, and then the bond between the carbon and oxygen is going to shift the electrons to the oxygen, and the bond between the carbon and the phosphorus is going to shift the electrons to the carbon-carbon bond, and that is going to form the alkene, which is the main point of the Wittig reaction. And now you have a pi bond and a sigma bond. So the main point of this experiment is to synthesize 1,4-diphenyl 1,3-butadiene using a Wittig reaction. So you start off with a methylbenzene, attacking it with a base, which is here as a hydroxide, and it's going to attack the hydrogen, and the electrons are going to shift to the carbon, forming a negative charge. And that negative charge, like before, is going to attack the phosphorus, which is positive, and it's going to form a bond. Remember, there's a resonance that occurs here because of the lone pair that can also form a bond between the phosphorus and the carbon. In next lab, we're going to use the cinnamaldehyde and react it with the Wittig reagent that we just created. So the negatively charged carbon in the Wittig reagent is going to attack the partially positive carbon in the carbonyl group, and the electrons are going to shift to the oxygen. Like we saw before, the negative charge on the oxygen is going to be attracted to the positive charge on the phosphorus, and that will form a cyclic intermediate. Cyclic intermediate, the carbon-oxygen bond is going to shift the electrons to the oxygen, like you're going to see now. And then the carbon-phosphorus bond is going to shift the electrons to the carbon-carbon bond, which forms the alkene that we want. And it's important to remember that there are two products that are formed here, the EE trans isomer and the EZ isomer. And since the starting product is a trans, the EE isomer is going to be the major product, just because that is thermodynamically more stable and there's less diaxial interactions. And that is it.